Hello and welcome to this edition of Learning R for Biostatistics and Biostatistical Calculations and Estimations. My name is Arindam Basu. I am a senior lecturer at the University of Canterbury at Christchurch, New Zealand. And I will be guiding you through these lessons the next few weeks to learn how to use R for your biostatistical data analysis. In the first lesson, we are going to learn how to obtain R from its CRAN repositories, how to install R, and how to use R in a general way. This is not going to be anything very specific or very special. We're just going to learn how you can also install additional packages to get your work going. And then in the second module, we are going to learn how to use the objects and functions in R, which are like the main building blocks, almost like cells in the human body. And then we are going to learn how to use graphics for your data analysis and functions. After we learn these three main ways of interacting with R, we shall learn how to use R for regression models and do your own work. Hopefully you will learn this and you'll find them interesting. And in each module, you will see a narrated PowerPoint version before an initial sort of introduction from my side. So thank you very much for your attention. Let's get started.
This particular lecture is going to give you a very basic introduction into R, particularly how you're going to obtain and install R, what R basically means, and how to use R for most productive work. We're also going to discuss in this lecture two specific items. First is how do we put data into R, and how do we take data out of R, because these two activities are the two most fundamental activities that you will be performing if you want to use R effectively, because those are the first and very basic things that you must do. In addition to those two essential activities, we're also going to cover some of the very basic ideas about getting R or obtaining R from different sources. So we start with a very basic introduction to R. We cover how do we obtain and install R and R Studio and R integrated development environment, which is a very, very important accompanying piece or accompanying software to work with R. We'll learn how do we put data into R, and we also learn how do we take data out of R. So the first question, of course, that comes to anybody's mind is this, that what is R and why should we use R? Because there are so many other different software that are available for data analysis. So what is special about R, and why are we insisting on, or why are we going to use R for that matter? The first thing that's very important to know about R is this, that R is a statistical programming environment, and this is a very important phrase to remember. There are many other packages that you can use in order to conduct your statistical data analysis. For example, statistical programming for social sciences, or SPSS, is a very popular package that people have been using for data analysis. Statistical Analysis System, or SAS, is also a very, very popular statistical data analysis package that people have been using. And indeed, there have been numerous statistical packages that people have built and people have used in a number of situations. What distinguishes R from the specific statistical packages is its emphasis on statistical programming environment, because it does not only give you an ability to write, conduct data analysis, read data, and then output data from R into elsewhere, but it actually enables you to extend R's functionalities by writing any number of packages, and then you can distribute it for free, or however may you want to modify this. Such fine-grained level of modification is not possible with the other commercially available statistical packages. Besides, statistical packages that are commercially available are also sold. In other words, they're available for a price, whereas with R, you get something that is available for free and it is open source, which means that when you use R, you can actually get to see what were the codes that were used to write R itself, and you can modify those codes. This is a bonus, and that is why the entire world of statistical programming environment using R becomes such a powerful concept for using your data analysis. I have been focusing on data analysis, but you can use R for more than just data analysis. You can use R for actually developing whole software, for instance, or you can use R for developing games that you can teach others. And you can integrate R with any number of writing environments, for example, LaTeX or Markdown, and we'll cover this in due course. So, to get started, the first things first, we need to obtain R from a source. And the best way to obtain R is to visit the CRAN website, or CRAN website. So CRAN, or CRAN, starts for Comprehensive R Archive Network, which means this is a website, and I say it's a website because it is it is a site that consists of a number of different pages, as we will see soon. And the URI, or URL, of that website is http://cran.artproject.org. However, as you understand, this is in order to obtain and access this site, you need to access the internet for doing this. You can just double-click on the binary file that is for your platform version, and then R will auto-install in your system, provided that you have got right to install a software. Now, what is a binary version? Many people have got many different kinds of operating systems, so it is not possible for the R developers to know, and the R developers, of course, have provided for each of these different platforms. Some people use Windows operating system. That is known as a platform. Other people use, maybe, for example, this particular lecture is being developed on a Macintosh operating system, or OS X. So that's another operating system. So for each operating system, the R developers have actually put together a binary version that you can then then you can double click and you can install them. So a binary version is a machine coded version that will directly install R into it. This is how the CRAN website looks like, and in the CRAN website you can see that on the left hand side, just below the icon of R, you can see that there is not only CRAN, but there are also a list of links. If you click each of these links, it will take you to a number of different areas in that website where you can visit a number of different things. For example, if you click on the documentation, you will see that there are many different ways in which R has been documented. There are full-length books that are put up in this site that you can read to learn more about R, that can go beyond this lecture. This is only an introductory lecture, so you can go beyond this and you can learn a lot more by reading those books, and I strongly encourage that you read those books. There is also extensive documentation of R. There is a very good group on the internet where R is discussed. It's known as rhelp.org. You should definitely look up those things. And you should also look up the R homepage and the R journal, as these are very, very useful resources for learning and staying up to date with our statistical programming environment. Now, this is about installation of the R package itself. Once you get into R, it's a very good practice to start learning about R by typing help.start and then put a parenthesis. We'll talk about that later. In addition to the base R package, which comes with a number of different functionalities, and you can do jolly well many good work. And what happens is that when R actually loads, the different packages that are contained within the base package also get loaded. So SAP packages within base package gets loaded. What is a package? A package essentially is a combination of data and functions. If you like, you can make your own package using your own sets of data that you'd like to distribute and the functions that you write there. So what has happened is this, that because R is free and open source and people have been using R extensively for their statistical data analysis work, Many professionals or many academics as well as other people have developed additional packages. We are not going to cover how to create packages in R, but there are whole modules and tutorials that you can access in order to create R packages. And these packages are kept in package repositories. It is a good idea to use the package repositories for working with R. In order to use a package, you will have to first install a package unless it is already pre-installed in your R installation. And in order to install that package, you have to issue a very simple command, which is like a function called install.packages. Note that it install.packages, not install.package. So you would use install.packages, and then you type the name of the package and indicate a repository. A repository is actually a website where the package information is kept, and the abbreviation for repositories is repos in the R options for this particular function. And the other thing, of course, it's mistaken here, but it's dependence. That is, what are the things that are dependent on it? What are the functionalities that are dependent on it? Unfortunately, there's a misspelling here. It's DEP, not DEEP. In order to use packages in your while working with R, you have to use commands such as library and the name of the package. You can also alternatively use the expression require and then name of the package. Next, let's learn how to use R with an integrated development environment. This is again a new term which we need to discuss a little bit. Now, it is always a good idea to use R with an integrated development environment. What is an integrated development environment? An integrated development environment is one in which you could actually write codes, but when you write code, you can also see the output of the code together with your code itself. When you work with R, you will be working with data sets, you will be working with graphs, you will be working with tables and some literal texts. Therefore, it is a good idea to have in one place an access to all of these different objects. Normally, in any R in any R console, you still have access to those elements, but they're not as visually or spatially present. And I'll show you in a second what I mean by this. So to repeat, integrated development environment is one which will help you to write codes, but you will also get to see the outputs and the objects, which are fundamental building blocks of R at the same time. The IDE used in this set of exercises is RStudio. Like R, RStudio is free and is open sourced, and you can download an RStudio desktop from rstudio.com website. So download the RStudio desktop version for your use in these modules. In order to correctly use RStudio, you have to install R first, and then you have to install RStudio. Here is the download page of RStudio. You can see that the download page of RStudio is shown here, and you can click on the download RStudio appropriate version for your platform in order to get your get it done. Once you have installed R and you've installed RStudio, this is how it looks like. Look, there are 4 individual windows here. Clockwise, the first one you get to see are a number of different kinds of commands that are given. Different kinds of objects that are present. And then in the window below that, it lists a number of different files that are present here. But in real life, you can adjust these windows and you can see how the outputs come out. Then you have got the R console, which is on the bottom and left quadrant of this square window. You can see the R console where many of the R commands will be actually executed. And on the top left window, the little square there, you can see that you can write actually the R code in the form of a .r file, and you can write your codes there. So now that we have learned a little bit about R and We have installed R and we have installed R Studio. Let's get started to start working on some of the most fundamental things about how to take data into R and how to take out data out of R. In general, in this lecture, I'm going to follow this following motif. You can see that there is a black box to your left, and then there is a white image where I'm going to show you the R console to the bottom and the code window on the top using RStudio. So we're going to write codes on the left side, and we're going to show you how these codes gets executed in the bottom window. Okay, so we shall we shall use some of the high impact points there, and we shall encourage that you practice with the codes. There is an accompanying RNW file, which is the the RNW file essentially is a SWeave file, which is an R woven file, and the woven is a weaving of codes and outputs together with some texts. And please practice with the RNW or the RWeave file with this. So what can we put in and what can we take out from R? Now you can take data from spreadsheets. You can take data from source code files. So if somebody has written a R file, the extension of R file is .r. So if somebody has written a source code file, you can put that as well. You can import data from other statistical data analysis software, for example, SAS, SPSS data using packages known as foreign. You can directly input text-based data. You can put table-based data. You can put images. You can put, you can do a lot of things. There are quite a few things that you can do with R. And certainly, I mean, you can do you can do a fair bit. For example, let's say you're reading a journal article and you see that there are certain numbers are presented in the journal article. What you can do is you can quickly, fire up your R statistical programming environment, and you can run some analysis based on the data present in that particular article. It's a very, very useful way of doing things. So let's see how do we input a source file. Now a source file is a file, and it's called a source file because it's a source of different R commands. So a source file is one in which it's a very simple plain text file. So you develop a source file in Notepad, for example. If you're using in any plain text editor, you can use to write a source file. Do not write a source file in Microsoft Word or any such specialized word processing program. They are not very good for that. But what are good for a very simple text editor will work excellent as a source file. So and you write the R codes, and you will learn how to write R codes in future modules. You just write the R codes and commands in R, and then what you do is this: that if you want to execute that source file itself, then type the command source, and then within parentheses you type the name of the file. Of course, you do understand where you're going to put R. The working directory has to be in the same place. So one of the other concepts of working with R is this: that you need to specify a working directory right in the beginning. So in one particular directory, you put all your data and all your codes. That's a very, very good practice, because then when you type source, then file.r, R is going to execute that command, and you will not get into any kind of errors. In our first instance, we are going to see how to read a comma-separated value file into R. A comma-separated value file is a very simple file which where all the variables, or it is actually a data file, where all the variables are present, but these are separated by commas. So, for example, in this particular file, you can see that the region of the country or the program type, etc. This was a data set that was taken to study from the internet. We put together a file where we looked at the rates of breast cancer screening in the different countries before and after the use of hormone replacement therapy. And the way this file was constructed is this: that in the first line, which is also known as a header line, you put the names of the variables. Then every subsequent line contains the individual values, and these values are separated by commas. So this is why this particular file is known as a comma separated value file or a CSV file. And these are very useful formats for actually reading data into R from spreadsheets and from other software. And indeed, from say even from the web and from other sources, if you want to put data, CSV is a very versatile way in which you can read files. And you can see that the way to read CSV is just simple as in English language. It's that read.csv and then put the name of the file, and then you see you say that the separator is a comma, therefore you say sep equals comma within quote marks, and you also indicate that the header are true. When that happens, R actually stores all those files in the form of an object. So when you say read CSV, always put read CSV into an object, and we'll learn about objects later. In addition to comma separated value file, which is a very versatile and very useful format of writing R files, you can also read other software files into R, because many people do their work in SAS or SPSS or Stata and other software. In order to do that, you will need to use a package. And one such package is known as the foreign package, F-O-R-E-I-G-N, the foreign package. You can also use another package known as HMISC package, and these packages were specially written for this particular purpose. If you want to read data from a Microsoft Excel spreadsheet, use the XLSX package to read data from Excels and spreadsheets. And essentially, it is very simple. You have to first load the needed package. For example, when R starts, type on the top of the header as a require foreign, and then you're all set. And then if you want to read, say, for example, an SPSS file, just type read.spss. Some software packages, for example, Stata, uses a file format which is known as DTA. So for reading files from Stata, use the command read.dta and then input the file name in it, and you will be able to read the file. So that is as simple as that. So let's get onto our next bit into how do we export files from. This is also another very important thing that you need to know, because as you can see, R basically is a very, very simple plain text environment. You can write a few codes, you can input data, you can run your analysis, but at some point you will also need to export everything that you've got into R into some other packages. The simplest and probably the quickest way to export data out of R is to use a command which is known as a sync, and use the function sync, and you start with the command sync, and then within parentheses write the name of the file that you want to put the data in. And you can actually sync anything between the sync and then when you close the sync. So in which you open the sync where you put the data out, and then you close the sync by just typing sync and then opening and closing the parentheses without writing any text in it. So sync function is a very useful function for exporting data out of R. Everything in R that you want to export, you can do that. Sometimes you would be interested to export tables, and so there's another way in which you can do this. Now, when you use table, so let's say you've got tabular data that after you have conducted a routine in data analysis, and you've gotten some figures in the form of table which you want to export. When you want to do this, use the command write.table and then put the parameters of those functions in there. The best way to do that is to specify a file name, typically a comma separated value file, because you can read that file into any spreadsheet and you can modify it in any way you like. And the best way to do that is to seek the help file for the right table, and you will understand what it is. But the command that you should be using is write.table. It's very, very useful. So now we have got a tour of the different things that you can do out of it. I have barely touched the surface of this. This was a basic introduction to R, but at least by the end of this module, you should be able to obtain R from the CRAN sources. You should be able to install R. You should be able to read in data into R, not only from a comma separated value file, but also from other statistical software packages. and you should be able to export data out of R. Okay. So when we do this, before I leave, let me suggest a workflow that you can use by using R. It's always a good idea to actually get all your data into a CSV or comma separated value format, and then you read the comma separated value format into R, and then process the data and run your analysis in R, recording as many packages as you need to do this work, and then push your files from R into other text files. That way R becomes a centerpiece of your data analysis. Now there's also another thing that you can do with R, particularly if you're working with RStudio. In RStudio, you can install a package known as knitr, or K-N-I-T-R. And what it helps you to do is this, that you can write not only R codes, but you can also write additional texts and annotations and figures and everything else, and then you can knit the entire R file into a very nice HTML file, or you can, if you use LaTeX, you can use R to weave weave R in LaTeX file. Many of these codes that I have written here were written actually using the RStudio knitr, to weave R with codes and texts. So you can very quickly, dynamically write reports that you can very easily manipulate using R. So to repeat, for a good workflow using R, you can put data into CSV format, you run your data sets, and you can run your analysis in R, and then you can export data out of R, and then you can get your things, get your work done. And R becomes the centerpiece of your data analysis. So good luck learning R and R's powerful function. So to summarize once more for the last time here, is this that you can input data into R from spreadsheets into a range of software, as you've seen. For this, you will need to install an HMIC packages in addition. Otherwise, use CSV files and read data into R. You can very easily export your tables from R to spreadsheets and process them. You can also sync files, just as you can source files, that is R source codes. You can sync an entire analysis file from R into another text file. So I think this concludes our first module. In our next module, we are going to learn about the concepts of objects and writing functions in R, and thereby we'll start with the first step of data pre-processing, and then we are going to take a look at images. And thank you very much for your attention.
Now that you had a set of instructions and lessons that you learned how to install R and how to obtain R from the CRAN archives, and you also learned in course of this little presentation how you can use R as a calculator, how you can use R for writing some simple programs, what R can do for you. It's time that we start moving on a little bit. In the next few lessons, you're going to first learn how to use objects and functions in R. Remember that R actually works using objects, and R is an object-oriented language, which means that everything in R is an object, and all objects have got classes. We'll learn a little bit more on this in the second module. You will also learn how to use and run functions, and you can call functions in the program itself and get some work done for your own work. After this, you will learn how to use R and use R for graphics, and then once you mastered these few things, then you should be able to write your own programs and work confidently using R. In addition to this, please pay attention to the R&W files and the PDFs that are accompanying these lessons. So let's get started with the next module. Thank you.